Assalamu alaikum. We know galvanometer is a device used for the measurement of current in a circuit. In this video, we will discuss few important parameters related with galvanometer. First, I'll tell you what is the figure of merit of a galvanometer. Figure of merit of a galvanometer. It is nothing but a current which produces a deflection of one scale division while flowing through a galvanometer. Write it on board. A current which produces a deflection of one scale division in a galvanometer is referred as figure of merit. Now, next, let me know what is sensitivity. Sensitivity of a galvanometer. A galvanometer is said to be sensitive when it produces large deflection for the passage of small current or voltage. Okay, so that way, first I'll tell you what is the current sensitivity of a galvanometer. Current sensitivity of a galvanometer. It is denoted by letter IS. IS, and it is nothing but the deflection produced per unit current flowing through the galvanometer. Okay. We know a galvanometer consists of a coil, a rectangular coil, through which when we pass current, it deflects in the presence of uniform magnetic field. This produces deflecting couple. As a result, the phosphor bronze strip with which it is suspended gets twisted. When the passage of current is stopped, the coil returns back to its original position due to the restoring couple produced in the phosphor bronze strip. Okay, so in that way, at equilibrium, we say at equilibrium, we have stated that this deflecting couple is found to be equal to the restoring couple. Here, deflecting couple is given as NBAI, which is equal to K theta. Here, K theta is nothing but the restoring couple. So, here, this is the restoring couple, and this represents the deflecting couple. Well, this we have studied in the previous video, which is about a moving coil galvanometer. To get more information about this, kindly go watch that video. Now, from here, I value can be obtained by cross multiplication. I need to keep I here, and remaining terms are taken to the right hand side. So I'll get this. I equals to K theta upon NBA. This is the value of I passing through the galvanometer. I box this and I name this one as equation number 1. Okay. Now, if you look at this equation carefully, you may find that it has got 5 terms: K, theta, N, B, and A on the right hand side. Out of them, K, N, B, and A are constant. Here K stands for restoring couple per unit twist, which is a constant for a given strip or wire. N is the number of turns in the coil, which is also a constant. B is the magnetic induction, which is again a constant for a given horseshoe magnet used in the galvanometer. Then A is the area of the coil. This is also a constant. So these four terms but a constant. So equation 1 can be written as I equals to constant multiplied with theta. So from this, now I name this constant. I denote it by letter G. I in the place of constant I write G. Here G is the galvanometer constant. This clearly shows that I is directly proportional to theta. As the current through the galvanometer increases, the angle of deflection shown by the galvanometer will also increase. This is what it means. Okay, now I take this one as equation number 2. I compare equation number 1 and 2. Comparing 1 and 2. What do I get? I get this. I get the value of G going to be equal to, here G is going to be equal to K upon NBA. Okay, this is taken as equation number 3. Alright, if I substitute this is the thing. Now my aim is to get the current sensitivity. So what is current sensitivity? Current sensitivity is IS, which is equal to theta upon I. So from equation 1, this can be obtained from equation 1. Here I have theta and I. What I do, I bring I this side and remaining terms are taken to that side. So I get this theta divided by I. It's taken from left hand side. Then this term K upon NPA is taken to the other side. I get this NBA, it gets reversed, NBA upon K. So it is nothing but the current sensitivity. What is this? Current sensitivity denoted by letter IES. So from here I can say current sensitivity IES is equal to NBA upon K. This is taken as equation number 4 for my convenience. Okay. Now if I compare equation 3 and 4, you may find that comparing 3 and 4. What do I understand? I understand that here G is a K upon NBA. Here I have NBA upon K, which is the reciprocal of G. So from equation number 3, it is clear that IS is nothing but the reciprocal of galvanometer constant. Okay, this is another. This is the relation between IS and G. This is another expression for current sensitivity. Okay. Now, what do we understand from equation number 4? Let me tell you. From equation 4, it is clear that the current sensitivity of the galvanometer depends on these 4 parameters. Current sensitivity, increases. If you want to increase current sensitivity, then what has to be done? Current sensitivity increases with increase in the value of N. If you can increase number of turns of the coil, current sensitivity will increase because it is present in numerator. In a similar way, current sensitivity can be increased if we increase the value of B, as it also present in numerator. Third, it can be increased by increasing the area of the coil. So I can say current sensitivity can be increased if we increase the number of turns of the coil, if we increase the magnetic induction, and it can be increased by increasing the area of the coil. Then IS value can also be increased by decreasing the value of K because it is present in denominator. So I can say this can be done by decreasing K value. Here K stands for restoring couple per unit twist. Okay. Here in the construction of galvanometer, usually phosphor bronze strip is used because the restoring couple per unit twist for phosphor bronze wire is very low. By using that, the current sensitivity of the galvanometer can be increased. Now, we'll discuss about voltage sensitivity. Voltage sensitivity of a galvanometer. Voltage sensitivity of a galvanometer is the repulsive VS, and it is nothing but the deflection produced per unit voltage across the galvanometer. So Vs is written as theta upon V. So from Ohm's law, we know, what does Ohm's law say? Ohm's law relates the voltage and current. It says that voltage across a conductor is the product of current and resistance. Yeah, so from this relation, the value of V is written as theta upon, in the place of V I write I. I is the current flowing through the galvanometer, and Rg is the resistance offered to the flow of current by the galvanometer. Right? Now we know the value of I, but I am going to substitute here from equation number 1. Substituting I value from equation number 1. So what I get this. Vs is going to be equal to theta, where written as it upon the place of I write this K theta upon NBA is multiplied with RG. Here, this theta and this theta will cancel. And in the next step, what do we get? See? Yeah, Vs equal to, we cancel, becomes 1. Okay, here we have 1 divided by K Rg divided by NBA. This is what we have in that equation. So this can be done in this manner. Vs is equal to When I take the reciprocal, when I take this to numerator, it becomes something like this. NBA upon K R G. So here NBA upon K is the reciprocal of equation number 3, the reciprocal of G. So from equation 3, this expression above this can be written as Bs equals to 1 upon G multiplied with R. This is the final expression for voltage sensitivity. Now, for better visibility, I box this. Now, from this expression, I name this one as equation number 5. This is equation number 6. From equation number 5, it is clear that the voltage sensitivity depends on N, B, A, K and R, G. Okay. Now I am going to relate the voltage sensitivity with the current sensitivity. So substituting equation number 4 in the 5. See what do I get? Then I have NBA upon K, which is equal to IS. So here I have NBA upon K. In the place of that, I write I. So here Vs is equal to NBA upon K is nothing but IS. From equation number 4. IS, in the place of this, I write IS divided by RG. This is the relation between voltage sensitivity and current sensitivity. So here, what you can understand from this relation? Let me tell you. Now one can say that if you increase the current sensitivity, voltage sensitivity may increase, but in reality, it doesn't happen so. When we increase the current sensitivity, along with that, the value of Rg also increases. So that keeps the voltage sensitivity a constant. Okay. So from this, we understand that the increase of current sensitivity do not increase the voltage sensitivity, because when you increase the current sensitivity, along with that, the resistance offered by the galvanometer to the flow of current also increases. So it becomes a constant. Clear? When we increase this also increases. So this remains a constant. This is what we understand from the final expression. Now here there is one more reason. Yes, here IS value depends on the number of turns in the coil. So if we increase the number of turns, automatically the resistance of the coil increases. So which do not change the voltage sensitivity of the given galvanometer. I hope the video is useful. If you have any kind of doubt related to the topic, can you put a question in the comment section? Thanks for watching.